Thermochemistry is the study of energy changes. And so how does the energy change in a chemical process? When we study thermochemistry, we need to identify a couple of things. You need to identify the system and you need to identify the surroundings. And so this is just a way of us of isolating something we want to study. So the system is what you're studying. And the surroundings is everything else, the rest of the universe, if you will. So example, if we had a beaker inside of a box, the beaker is what we want to study. The beaker would be our system, and the box would be our surroundings, and that box can extend infinitely out in all directions, and we could call it the universe. But anyway, the system and the surroundings. When you're studying something in thermochemistry, and you're studying the energy flow in thermochemistry, energy will either it will do one of two things. It will flow out of the system into the surroundings, or it will flow in from the surroundings into the system. And so that direction of flow of energy determines whether or not the reaction is an exothermic or an endothermic process. And so you already know what those words mean. Exo energy goes out, endo energy comes in. But it always transfers between the system and its surroundings. Heat always flows from high energy to low energy. And so if the surroundings are hot and the system is cold, energy will flow in to the system, or sorry, into this system. If the system is hot and the surroundings are cold, energy will flow out of the system. That is a natural process. So what is heat? We need to know what heat is. Heat is the flow of energy. That's what heat is. It's the flow of energy from an area of high energy to low energy. We symbolize heat by the letter Q, a lowercase q. And so we need to know that heat is Q, and it's the flow of energy. And so if you have an exothermic process, Q flows out. If you have an endothermic process, Q flows in. Specific heat capacity. This is a measurement of how much heat it takes to change the temperature of a substance, in this case 1 gram of a substance, by 1 degree Celsius. So for example, if I had a little block of aluminum or something, and aluminum was at 25 degrees Celsius, and say this was 1 gram of aluminum, and it was at 25 degrees Celsius. If I wanted to raise the temperature of that block to 26 degrees Celsius, I would need to add to it heat, Q, would need to flow in to the block. Now, how much Q do I need to add to the block to raise the temperature 1 degree Celsius? Well, the amount that I need to add is the specific heat capacity. That's what we define that as. And so however much heat that is, you need to add it to raise the temperature of 1 gram by a delta T of 1 degree Celsius. In this case, 25 to 26. If I wanted to go from 26 to 27, it would be the same amount of heat that I need to add. Every degree change requires whatever that specific heat capacity is for 1 gram. If I had 2 grams, it would be twice that much heat. But when we use the word specific heat capacity, that refers to 1 gram of the substance. And so different substances have different specific heat capacities. What that means is different substances will respond to heat in different ways. For aluminum, it's 0.9 joules. 0.9 joules per gram degree Celsius. That would be the specific heat capacity of aluminum. And so if I want to raise this by 1 degree, I need to add 0.9 grams of heat. Joules is a unit of energy. 1 gram, 1 degree Celsius, 0.9. Water, on the other hand, has a heat capacity of 4.18 joules per gram degree Celsius. So if I have 1 gram of water and I want to raise its temperature up by 1 degree, I need to add 4.18 joules of energy. Water has a higher specific heat capacity than aluminum. It takes lots of energy to heat up water. It doesn't take much energy to heat up aluminum. And so the higher the number, the more energy it takes to change its temperature. which that's a good thing in the case of water. We don't want water temperature changing rapidly throughout the daytime and evening temperatures with the sun heating it. So you need to know what heat capacity is. A formula that we will use, we'll get right into the formula for this, is this. Q equals mc delta T. This is what we're going to do in class tomorrow. Q is obviously heat. M is mass. C is the specific heat capacity. We will get that from a table, or you'll determine it from an experiment. And delta T is obviously the change in temp. And so Q equals mc delta T is the first formula that we will be using with thermochemistry. So if I have some substance, some mass of a substance, and I want to heat it or cool it by some temperature, I use the heat capacity, and that tells me how much heat I need to add or take away from that substance. One way to remember this formula is mc delta T, looks like MCAT. That's a test to take. I think this is the med school test, MCAT. So Q equals MCAT is one way to say that quite often. And so that's it. We'll see you tomorrow.